we're going to be exploring the depths of UART, and we have one of our hardware pen testing experts with us.
And also we are also emerging through the healthcare and then security like drones, everything we are taking a part in that, all things.
We're going to be reverse engineering and looking at those things live with you guys. Let's talk about the applications of UART. What are the common use cases in embedded systems? What are the common issues that you usually face during UART communication?
Capacitors and the relay, everything is there already, right? In the back side, if you can check, the button is also given. Because of that, we are like turning on and off of the switch.
Hey guys, welcome to another fantastic podcast by Redfox Security. I am Karan. I am the CEO and technical director at Redfox. What we pretty much do is pen testing, right from infrastructure pen testing to Active Directory, to application security, to hardware security assessments, industrial control systems, and you name it, right? So we also have like our academy channel where we are training professionals just like you. We also train at conferences, so there's a lot of exciting stuff. Please subscribe to our channel, follow us on various socials. We are live on LinkedIn, a lot of chatter happening on Instagram as well, so please follow us. Today is a fascinating topic. We're going to be exploring the depths of UART, and we have one of our hardware pen testing experts with us, Shravan. Shravan, first introduce yourself and then we can get started.
Sure, sir. Thank you, sir. Yeah. My name is Shravan Singh and I am a security consultant at Redfox Security, and I just take over here as a pen testing of the embedded devices, and also we are working on the finding of vulnerability assessment and pen testing on the embedded devices, and also we are also emerging through the healthcare and then security like drones, everything we are taking a part in that, all things, and slowly we are increasing our firm so that we can test other products also. So we are making the environmental more secure, so that's why we are working on the embedded devices to be at a security purpose. So yeah, that's it.
Fantastic. Okay, so we'll just dive straight on. Guys, stay tuned. We have an exciting video that Shravan has developed. We're going to be reverse engineering and looking at those things live with you guys. So stay on. We're just going to go into a bit of depth and then we'll go into the practicals. Right. So Shravan, let's start off. Can you briefly introduce what UART is and what is its importance in modern technology?
Right. Yeah. Great. So we are in this podcast, we are talking about the UART, right? So what is UART and how does it work and what are the types? So we will cover all the topics in this podcast. So slowly, and also we have demonstrations of the UART. So we have one of the device with us. So we will do the reverse engineering on that device and we will see how the UART works in that device. So we have a video on that. So stay tuned for that, for the later on that with this podcast. So what is UART, right? So in the UART, so this is the one of the protocols which we are using in the devices of embedded devices, IoT devices, so that we can have an access from the backside of the device, so that we can interact with the boot kernel of the device, so that we can check how it is functioning and whether it is where the problem is existing in the device. So we can check through the protocol of the UART. So UART is a universal asynchronous receiver transmitter. It uses in the without a clock. So we can, whatever the data is there, so we can interact with the device with the data is a communication through whatever the data is running in the device, so we can check it from the back side. And also, one second. Okay. So from the UART introduction, so what are the UART, right? So it's a universal asynchronous receiver and transmitter. As you can check here in the image, there are 4 points over there. The test pins are there. So wherever you can check in the PCB, in the devices, if it is the 4 pins are there, then they are the subjected to a UART. So as you can check, like the 4 pins are already there in the silver coating. So we can assume that the 4 pins is of UART. So UART is consisting of 4 pins, that is like RX, that is receiver, TX transmitter, GND for the ground, and the VCC for the power supply. Power supplies depend upon the 3 volt, 5 volt, depend upon the devices, which devices we are using. So these are the devices which we are using in modern technology. So modern technology, like if we are connecting with the device like home automations, and also the embedded devices which we are having a microcontrollers, computers. So these all the devices are having the UART, so that we can have an interactions with the device with our monitor, so that we can check how the boot process is working and the kernel images are working. So these are all the things are essential in communications in consumer electronic and telecommunications.
Excellent. So that was quite a bit of information. Uh, so let's move our attention towards the history and evolution of UART. What are the origins of it? The key milestones in its development, and the transition from hardware to modern implementations. Right. So can you briefly explain what all of this is, and maybe for our viewers, they can understand. Folks who are getting into hardware pen testing, they get a better understanding of what UART is, right? Yeah.
Sure, definitely. So let's see how the UART organize and how does it come into industry, right? So in the history beyond, like we are using the RS-242, 232, and then these protocols are using the back in the era. So for that, for more convenience to use, like if for the interactions. So from the small microcontrollers, like if you can take an example, as you can see in the Arduino Mega we are using over there. So from the Arduino Mega, Arduino Nano, Arduino Uno, so we are using the like RX TX pins, so that we can have a communications with like peripherals, like whatever peripherals we are using, like LED, motors, and whichever we are using with the Arduino microcontroller, so that we can have an interaction with how it is like turning on, off, and then if it is working or not working, if the malfunctions or troubleshootings occurs, and then if we are not like getting how it is not working in the front end. So for the checking purpose, if we are communicating with the microcontroller, then in the backend process we can check whether what the problem occurs and where it is stuck. So for that communications purpose, and then protocols which we are using the outdated is like RS-232. Instead of that, more modernizations, and also for more reliable, so we are using the UART. If you can check, like the newly devices also are inbuilt with the UART, because UART is most commonly used, and also that is like very user friendly, so that we can have an interaction. So there are like certain like pins and every we have two type of wires in like like half duplex and full duplex. In half duplex, one directions data transmit from the device to the peripherals, and then two directions is like the two wire we are using like for the data transmissions from the device and the peripheral, so that we can have an access to read and write of the data at a times from the UART section. So we are using the UART for the transmitting of data from, and also we can check like whether the device is working correctly or not. So these are all the things. Because of that, the UART came into picture, and also the more convenience to use. So that's why we are using in the modern technology also. And the previously in 1960s we have already developed the UART. So that's why from there to in the modern technologies we are using the UART.
Wow. So this is there's so many applications here when it comes to UART, and in terms of hardware hacking as well, hardware pen testing. Just a disclaimer, guys. Whatever we are disclosing here, please do not use this out in the live. Take proper permission from the relevant parties. So just a disclaimer here, right? So now we'll actually move into how UART works, the serial communication part, the breakdown of the UART protocol, and we're going to briefly touch base on baud rate, start bits, stop bits, and parity.
Sure.
Right. So on to you, Shravan.
So how does UART works, right? So what it consists of? Okay, so in the UART, if you can check, then there is a frame rate. Okay, in UART frame, so there are total 4 sections. Like if you compare with the other protocols of serial communications, then there is like a clock is there already. So it depends upon the clock, how it start, like where it is start. So clock will be like generate the pulse so that we can actually know when the data is transmitting and when the data is receiving. Okay, but in the section of UART it is unsynchronized. Because of that we are not having the clock. Because of that we are unable to know that where the data are starting and ending. Because of that we are having one of the section in the UART frame is start bit. In the start bit we will get to know that when the data is transmitting, and also from the stop bit we can get to know that here the data is ending. And then in the middle of that part we have a message bits that the character is of 0 to 7 of bits, total 8 bits data are there. So we can send a message of, and whatever the messages are there, like whatever binaries are there, so we can keep into the message bits. And along with that we have a parity bits also. In the parity bits, if you can see, then if you have an errorness or something extra bits of data, then we can adjust in the parity bits, so we can transmit the data along with the start, message bits, parity bits, and stop bits. And also we have most importantly thing, that is the baud rate. If you are having a device and you are connecting the device with the terminal, then if you don't know about the baud rate, then there will be a bigger mistake, because then the data will not be displayed as per your need. Because if you know about the baud rate, how it is functioning, like 9600, 115200, 57600, so it depends upon the baud rate how it is functioning the device. If you can check, then if we are having an access to UART functionality, then there is a dedicated UART like a baud rate from the company itself. If you have access to, if you can check it like 57600 is for example, then data will be displayed as per the boot kernel, and images and the root shell access, everything will be displayed along with that. But what if the company is like a block, and also like sometimes what they do is like they disable the UART pins. Because of that the baud rate also not work. So it depends upon the how the companies is like reacting to the security concern. So this is how the UART works, like with consisting of the start bit, end bits, and message bits, and along with that parity bits. And also the baud rate should be known about that. Because of that we can have an human readable data.
Okay, wow, that was a lot of information. I learned quite a bit. Now, let's talk about the applications of UART. What are the common use cases in embedded systems? Examples in consumer electronics and telecommunications, and how would you compare it with other protocols, right? So that'll be SPI, I2C, and other ones, right? So yeah, Shravan, please.
Okay, so for the UART sections, like if you consider applications, there are loads of applications. If you can see the home automations, if you have in smart home automations and ecosystems, whichever, like if you can take an example of Alexa, like more secure devices. So in that also what they do is like for communication purpose, they just keep like most of the test pins like JTAG, UART, SPI, I2C. So because of that the interaction is very much friendly and easier, but it depends upon the company like Amazon or Chinese products or other companies. So it depends how they are like reacting to the security purpose, right? So in as per the Amazon or any of the services, as we have already worked on the devices, so they are, what they do is like secure protocol, secure boot process. So they just take all the considerations and they take the accordingly. But like mostly companies like if you can take an example of a Chinese company, what they do is like they are just making a product for the industry. They are making just for like introduce in the industry, and then after that the product will be like distributed to the home consumers. So in that devices, if you can check, the UART section is easily accessible, and from the device you can check the whole boot process, kernel image, and all the data which are transmitting. If you can have an the Wi-Fi module inbuilt, then there will be a more problem with that, because the SSID, password, all are in the clear text, because they are not in putting the efforts to the encrypting the data. Because of that, this is very severe issues, and these are the applications where the UART can be used in the home automations, and also the devices which are at a higher scale like in industry and then ICS. So these all the industries are using the UART. And also if you can see in the smartphone, GPS module, modems, these are all the in the routers also, in the all the things are consisting of the UART. If the JTAG is not present, but the UART has to be there, because the most interactions part of that the device. And also if you can have a look into the image of this, so you can check it as this is a tool of TTL to USB. So from these tools we can have an easily accessible of UART communications. As you can check here is 5 pins over here, like 3v3, TX, RX, GND, and then 5 volt again voltage. So in this also, if you can check TX and RX is main pins of the UART. So from that the receiving and transmitting text part, and then the 3v3 is for optional. Because of that, if you have a device power, then we don't need in the 3v3 and 5 volt. And the third one, from after the RX and TX, there is a GND for the common ground, so that after connecting the RX to TX, TX to RX, and GND to GND, we have an like a Picocom screen and then Arduino IDE software, so that we can have an interaction with the UART of a boot process and everything, whatever the root shell access, whatever going on. And as compared to the other protocols like SPI, I2C, and JTAG, so why UART is common and why it is essential, right? So in SPI, I2C, these are the clock based, and also they are the one half duplex and full duplex. In I2C, if you can check, then the messages are transmitting interconnected circuit. So one at a time we can transmit we can transmit the data in one frame. Like if we can read it, then only we can read it. If we can write it, then only we can write it. Or in SPI, there is a based of we have like data. If we are selecting slave and masters, if we have a different multiple slaves, then only master will be it will work on the master's way, and the slave will be like peripherals, and then multiple masters will be there, then one slave will be organized with the messages. So it depends upon the clock how it is organizing, because that's why they are more complex way. And in UART, if you are connecting, then the boot process we can dump the firmware, and then we can analyze the firmware in serially. Okay, so that's why the UART is very commonly and user friendly protocols. And in JTAG also there are multiple pins, because of that that is more complex way. And SWD and other protocol also there, but they are more complex and not user friendly. And UART is more user friendly, and it is easy to use. And also this is consisting of 4 pin, that is VCC, GND, RX, and TX. That's it.
Excellent. So coming to the next section, troubleshooting UART communication. what are the common issues that you usually face during UART communication? And for our viewers, what are the tips and tricks for debugging these issues when it comes to UART connections? Yeah, Shravan.
Okay, so for like troubleshooting of UART communications, like if you are connecting UART, like firstly, if you are connecting correctly pins from the UART to the device, and then if we can check the garbage data, gibberish data in our serial monitor, then there will be a baud rate mismatch. Sometimes what they do is like keeping the lower baud rate like 9600 and the 4800. So as per the company standards what they are keeping, so there is a range of baud rate, so 115200, but the company depends upon the company what they are keeping. So because of that the baud rate mismatch problems occur. And also if the baud rate is correctly, and also if we are not see the data in the serial communication, there will be an issue of wiring. Like if we are connecting the RxTX, and also sometimes what the vendor do is like they are just removing the tag of the pins. Okay, so RX, TX, ZND, VCC and multiple test pins are there. So from that we are analyzing, and then if we are having a wiring of the test pins, then there will be a problem. Like if we can detect the problem correctly of the test pins or not, then that's the problem because of the wiring issues. And if we are coming overview with that, so for that wiring issues we need to check with the multimeter and then oscilloscope. From that we need to check whether how much power it is inserting, and also from oscilloscope, so we can check the RxTX how it is taking the data and the receiving and then transmitting the data. For the GND and VCC we can check through the multimeter by continuity test and then voltage voltmeter. So these are the process we can come over through from the wiring. But for the baud rate mismatch we need to check all the baud rate from 9600, or also we can go for the lower version also 4800 through till then 115200. So we can check all the baud rates, and from that all the baud rates we can have an access to it. And then once the data is in the human readable form, then the data will be the baud rate problems will be solved. So these are the troubleshoots when we are connecting the UART to the device. So these are the common problems occurs when we are connecting the device.
Nice. Now let's talk about the future of UART. That's probably the last slide, I guess. Yeah. What are the emerging trends and innovations and potential challenges and opportunities in this space?
Right. Mm-hmm. So, okay, so now what the industry is working is like healthcare components. Okay, mostly healthcare components are like used in the medical and then in the hospital itself. So, sometimes if somebody is using some TTL, USB or some other whatever the device they are taking along with them, and they just insert it through the device itself, and they can have an access to the whatever the device of the patient's data and whatever the device root shell access, whatever the password keeping. So in the medical devices are bigger and also they are more costlier. So that's why there has to be a back end backdoor UART JTAG, so that they have a communications whether where it is the problem occurs and then how can they resolve it. So that's why they are keeping the serial communications. And also if you can see the drones for the national security or somewhere else, so if you can check the drones also, then they will be they are keeping for the troubleshooting purpose RF challenges already there because of that SDR software defined radio. Because of that they are securing more and more. But in the protocol part they are keeping test pins UART JTAGs mostly untagged only. So because of that we can have an access to the device and we can dump the firmware from that firmware we can analyze each and everything, so that we can have an access to that device. We have an vulnerabilities in the firmware. If it is there, then we can find it out, and then we can have perform it with the other drones also. So for that, like UART pins are already there in the devices. And also for the security, for emerging like integrations in the IoT devices, the UART is compulsory. And if you are want to secure it, like more challenges are coming like secure purpose, right? So for that challenges perspectives, if vendor are approaching to the UART, then at the end, if they are supplying it to the consumer, then before the supplying, so they has to be cut off the disable the UART pin sections. So that's why because of that, the consumer and then whoever attackers are there, so who are working on the researcher part and then ethically, non-ethically, so they will not have an access to the UART section. Because of that, they can't have an access to the boot terminal, kernel terminal, firmware. So they will whatever the firmware is running in the device, like live firmware, they can have an interaction if the UART is not disabled. If the UART is disabled, they can't have an access to the firmware. If they can have an access to the firmware, they can go for the SPI, EMMC, and then flash ROM. So there will be a no live firmware. Because of that, the encryptions is more like PGP encryption, SHA-256, 512. This encryption is already there. But if they are going for the live firmware, then there has to be a UART section. If it is disable by the vendor for each of the devices, then they will be more good for that. Because of that, these are all the challenges they are facing, and UART section is to be more improved. And also for the root shell access from the UART only. So what the vendors is do, previously we have also found the vulnerabilities in LB-Link. So what they keep is they kept the firmware password and then root shell access password default only. Because of that, we directly interact with the root shell access. This is very frustrating to the users. Because of that, the data are leak over that. And also we can have an access to the whole the firmware and all the file systems of the device. So these are the challenges faced by the vendors. And also because of these overcomings, they can disable the in each of the device by disabling the pins of the UART, and they have an easy access to the device.
Okay, wow. Okay, so we touched base on a lot of topics. I think you have gone really deep into the history of UART, how it works, the applications, common tips and tricks, troubleshooting. Now it's time to take a few questions. So Avinash is asking, can you share a project where UART played a critical role in communication between devices?
Yeah, we will definitely we have multiple projects. Okay, so in the most of the devices, what we are going through, if they are more secure, when we are connecting the device with the root shell access, if you can check the backend chips are more secure. Okay, and then encryptions level are also higher. And mostly companies right now like Wipro, Amazon, these all the companies are using the in even the TP-Link also, the TEPO devices, they are using the backend chips. In the backend chips, what they do is they are organizing each and everything. And also the flash chips, that is the SoC, system on chip, in that all the encryptions are tighter. And then also if we are dumping and then if we are checking the boot process, then there will be a lock functions, and from that we can't have an directly access to that. But in sometimes the users of most of the new industries, what if they are using the backend chips, then there will be a more more unsecure part, that if the chip is reading by the backend, it's also BK723N. So from that we can have a firmware key and everything. So in the demonstrations right now in the video also, we will check the backend chip only. So in that also they are exposing with the keys and everything, so that is very harmful. So because of that, the backend chips at the one one side is very good because of the more encryptions is there, and we can't have directly access to the root shell access and boot process kernel. So this is good. And in the other hand, like the ESP module, like in ESP module there is like open source. Because of that, like very cheaply devices which they are using are ESP module, and they directly connect with your router, and the router password and everything are exposing in the ESP module. And because of that, like sensitive part, so the user home and ecosystems are getting compromised. So because of that, there has to be a more good way to the good company, and also they need to be having good chip like backend chips and other chipset like SoC and then QFN packages. So these are the good packages. So interaction with these chips, we have an good projects and good deal.
Excellent. So we have two more questions. In just a minute, let's address them and then we move into the practicals, right? Srishti is asking, what security consideration do you think are important when using UART in embedded systems?
See, I already told about what consideration has to be there in security. Like whenever you are using UART section, so from the vendor perspective, there has to be disabled in each of the devices the test pins, so that nobody have an access to that. And even if you are having the reset buttons, so whenever we are like getting an access to the device, then there has to be a mechanism like there has to be reset the device again, so that we can't have an access to the whatever the boot process is there. So it will be resetted again and then again and again, so that we can't have an access. So these are the simple implementation. And also, instead of the UART, if you are using the chip, then go for the OTP, like one time programmable, and then there is no requirement of UART also.
Excellent. And the other question by Srishti, one more. What are the key factors you consider when choosing UART settings like baud rate, parity, and stop bits?
Yeah, see, in UART, if you are consisting of the baud rate and then start bit, stop bit messages, so it depends upon the devices. So what the devices are using, like which like architectures they are using, MIPS, ARMS, and then whatever the x86, whatever the devices they are using. So according to that, the messages bits are like more it depends upon the complex part. So from that we can check like whatever the device is there, and then we can check the file systems. Like if it is MIPS, they're like Linux based, then there will be a more easier way, and then we have directly access to it. And then if it is ARM and then other x86, then we have like very much complex of the file systems of that. Because of that, the start, stop bit, and then message bits, and then parity bits, the errorness will occur and more and more.
Excellent. Okay, so that's a lot of stuff in. Now I think the viewers want to see the practicals. Let's just dive in. You can actually explain while...
Sure, definitely.
Yeah.
Okay. So yeah, let's get started with the practical. So in the practical, so we are having a we took one device that uses in the home automations, that is the smart plug of 16 ampere. So we are keeping the name as a confidential. So this device is used to work in the Wi-Fi, and then also because of this device we can have we can control anything like a fan, geyser, and anything. And right now we are talking about the UART sections. So we directly jump into the UART sections. We have already initialized the device and feed the data, whatever that. And then after that, now we have directly access to the PCB. So in PCB, the first thing is that we have to recognize each and everything from the PCB itself. And also the main thing is like UART sections, right? So from that, now as you can see in the PCB, it consisting of the chipset, and then this capacitors and the relay, everything is there already, right? In the back side, if you can check, the button is also given. Because of that, we are turning on and off of the switch automatically. And back side, we have multiple test pins over there, PCB communications, they are already connected with one to other. Now we are directly jumping into the chips which we are using the UART communications. So as you can see, the chip which we can see here is a Wi-Fi module over here, which is of backend chip. So in the backend chips we having multiples like registers is there, antenna, clock, and then SoC chip is there. So from these chips we are going to see now the UART pins, that is the RX, TX, GND, VCC. From this, the backend chips is consist of multiple chips, that is as you can see here, the RX and TX pin is already visible, right? RX2 and TX2. These pins, because of that we have an interaction to directly the firmware of the chip and the whatever the device is consisting. And the backside there is 3v3, GND, RX, TX, 1, and then P24, P26. These are the other pins which is consisting of by the chipsets only, backend of. And from this only the main chips are main pins are RX and TX and GND, VCC. Now we are not like disassembling the chip from the device. In the device itself we will going to solder the pin, and from that we will have an engage with the UART sections, right? So now we will directly solder the chip one by one. So we'll start with the in the front end also, as you can check there is a 5 pins. So in that one RST pin is there, we will solder it. Now first we will apply the flux over here, the solder flux. Okay, so from that so that each of them, while we are soldering the wiring, so each of them has to be at a specific point and they will be not engaged with the others. So now we are going to be solder each of the pins. We have already the chip lines. So now we are going to connect with the one by one, like GND, RX, TX, and then reset pin. Okay, and in the front end also we will apply the flux, so that they are very very minute pins. As you can see, these are very small chip, okay, the pins. So we will connect them like RX and TX. So these are very complex part, so we should be like very careful. So we will now have an wiring. Okay, so from that wiring, so we'll connect the these are the smaller wire. So we are connecting the RX and TX2 from here, and from the back end we will connect the GND and VCC. So from the the pins which is TX2 and RX2, we are connecting with the wiring, that is the conductive wire which we are using, the electric wire. Because of that we can transfer the data from one end to another end. We have already checked the multimeter. By multimeters we can check the data in the continuity mode, like one end to another end. So TX2 is already soldered. Now we will solder the RX2 also, so that we have a communications of UART. So now we have the other part also connected, and now we are connecting the other part, that is this one is a VCC. So 3v3 voltages, and now we will connect the GND. So GND pin is used to ground the whatever the device is working on. And the last pin, that is like reset pin. Because of the reset pins, while we are tapping into the ground, the reset pin, then the boot process will start, and then we can interrupt the boot process in between to get a root shell. So this is the reset pin which we are soldering at the another side. So the reset pin is also known as, in some devices, is CEN pin. So now we have connected with all the pins RX, TX, and other. So the extra flux will be removed, and then we will clean the pad. And now the RX and TX is very smaller pins, right? So they are very minute and also complex. Because of that we are connecting that pins to the other PCB, so that we can have easy access. So now we have directly connected to that. Now all the things is connected. Now what we do is get a connected connections with the UART. So we will use the TTL to USB communications. So from that we have directly interactions with the devices like software like Arduino IDE and Picocom, Minicom, Putty, whatever devices we are using. So in this device we have already have all the communications. This is TTL to USB, that is CP2102, and now in that also we have as you can see the pins, that is GND, VCC, RX, TX for the chips. Now we are connecting the pins in the RX has to be go into the TX, and TX has to be go into the RX, GND to GND, and VCC has to be in 3v3 voltage, or as per the device need like a 5 voltage or 3v3 voltage. So after connecting, so we have a terminal over here. So in that we are using Picocom. In Picocom, as you can see, the command is that Picocom -B, B means baud rate, that we are using. The first is 57600, and the port which we have connected like /dev and /tty USB 0. So in that we have connected, and then we have also connected the device into our monitor. So for that we can have an easy access like how the reset pin is working. So because of that we have a small dialog of a device also. And while running the code, so as you can see, the more details of the Picocom is shown, like version v 3.01 is using, and the rest of all the commands. Now we are going to interrupt the reset pin with the ground, so that we can directly have an access to the terminal. So terminal is ready, and now we are interrupting. As you can see, the datas are very garbage and non-human readable, right? So because of this, this occurs because of the mismatch of baud rate. So now what we do is like stop the process and remove the device. Okay, and also we are again writing the code. We'll clear it first, and then again we will go for the Picocom command. And while changing the baud rate, like we have previously, baud rate is of 57600, now we are going to use 115200. So we are like changing the baud rate, as you can have a baud rate of 9600 and any other also. Again, while we are connecting the power to the device, and also we are connected the device. Now again we are running the command, and again we will interrupt the device in between by reset. So again by interrupting, again we are getting the human readable form, right? So we have a data of a human readable form, and also the servers and every data of the boot kernel, all the data are visible. So again now we will see what data we have occurred. Okay, so from that beginning, so in the Picocom, so we have begun with the Picocom command. So each of the details of the Picocom is in the front, and then after that the chipset name and what are the addresses, registers, and they are all mentioned by the chips, what the devices are using. As you can see, the chip is using the Tuya, right? So Tuya is a cloud. So this is a cloud forms where the data is storing. Like we are using the one Chinese product, so this is the like firmware, the Tuya, which is storing. So these are all stored in the Chinese cloud market. So because of that these are insecure, and also as you can see there are multiple datas which are here. So the when the Tuya like implemented like in September, and like mostly very old versions, and these are the registers where the datas are stored, and then other things which we go for, and like we can analyze all the datas here also. And then after that if we are going for the higher data, so we will see each and of the data, like we have a read of the commands, and also if you can see there is a SSID mentions, right? So chip data is mentioned over there of course, so that we can have an easy access to the chip also of EEPROM and everything. Now we will go for the datas which are like very sensitive, so we will go one by one. So here are more datas are there, we will go cover it each in detail. So now as you can see, there is like SSID. So now we are using it without like implementing datas and SSID of the routers without connecting of that. Because of that, we can see the SSID name, which is Tuyadev. The default test ID is given. So, and also we can see the datas which are here, and the most confidentially datas which we can see here, as a product key is visible in the clear text, and also along with the product key there is a firmware key, and below of that. So that is main concern of the device. Because of this, the product key, firmware key, by using this all the keys we can like decrypt the firmware, and then after that we can analyze the firmware thoroughly, and also we will reverse engineering each of the part by doing the gidra and everything. We have also the series coming in the days, so in also we are covering up the reverse engineering of the part of the binaries analysis. These are the all the binaries we are going to analyze, and from that we can analyze the vulnerability finding and how the gidra is working, reverse engineering, all the things. In that the firmware key and everything, the confidential data is there from the UART section. These are the important things which we are getting from here to get it, and then we can analyze in the gidra. So these are the main confidentials. And also from the side of UART, so you can get an root shell access also whenever you are having a device with the root shell access or some. There are some multiple commands is there in which section you want to go, tftp, file transfer, or some like a CLI command. So you can have an interruptions, and then you can print your environmental variable, and you have interruptions of boot, and then after that you can have a directly access to the root shell access. Or sometimes the what vendors do is like keeping the password very strongly, or sometimes they are keeping like a default only. Because of that, easy access to the root shell access is also very harmful. So these are all the things we can do through the UART. So this is the practicals which is covering of how the boot is boot is working, and also how we can go into the keys and the datas which are running from the back side of the device. So these all the things which we are covering to the UART. And then the next section is analyzing of the binary, dumping the binary, how we are dumping the binary from the UART section, and also how we are analyzing from firmware like binary file in the gidra. So we are having a series coming, so stay tuned for that. And
yeah, perfect. So this was a fantastic session. We covered a lot. We started off from introducing what UART is, the history and evolution of UART, how it works, the applications of UART, troubleshooting, the future, and we tried to take as many questions as we could. There is actually one more question by Anix. How do you integrate UART communication in a system with multiple devices or microcontrollers?
okay, so what we do is like when we are connecting the device and the UART, so multiple devices, like if we having an here is like a transmitting and receiving. So when we are connecting to multiple devices, then there will be transmitting and receiving, but they will be work as a slave and masters. Like if one microcontroller will be there and then other devices, then there will be need of RxTX of UART section has to be there. So we can communicate with the two times, like we can transmit it one time and then we can receive it one time. So this is like a read and write process. So there, as you can see in the our demo session also, there is a TX2 and RX2. Because of that, we have a directly accessing of reading the process, and now all the data which is human readable and non-readables are in the format of reading process. And for the writing process, we have an TX1 and RX1. From that communications, we have an directly communicate with the other devices.
Excellent. Okay, so next week, probably the next part of this podcast, you briefly mentioned we are going to get into reverse engineering,
right,
and other parts of hardware pen testing. So just to help people get into this space as well. So as you said, let's go after reverse engineering.
Right.
We'll start a series of podcast. So, guys, that's going to come in. I really encourage you guys to get into, different kind of projects when it comes to hardware. Pick up a device and try to understand how it works. But again, a disclaimer, don't try to hack devices. It's illegal, and you can get it, you can go into jail for that.
But
right?
be ethically, right?
Yeah. Be ethical. I mean, follow the process, the procedures in any country you are, right? So you got to follow that. So thank you all very much. I really appreciate you joining us for this wonderful podcast. Thank you, Shravan. Thank you to Mahesh and Anil. Thank you, everyone. The guys who are working behind the scenes, they're doing a fantastic job. So stay tuned. Follow us on different channels, on YouTube, on LinkedIn, on Instagram, on Facebook, and on any other channel you see. Thank you very much. Till next time, goodbye and take care. Thank you.